Welcome everyone, thanks for coming. My name is Bigos and I am open source developer at OpenZeppelin. And today we're gonna talk about Arbitrum Stylus. So let's start with the question, what is Arbitrum Stylus? So before Arbitrum Stylus was enabled on Arbitrum chains, Arbitrum nodes hosted only EVM. Arbitrum Stylus adds additional co-equal virtual machine, WASM virtual machine. And that virtual machine allows us to develop smart contracts in any programming language that compiles to WASM. At this point, I need to mention that WASM smart contracts are fully interoperable with Solidity ones, which means that we can call either WASM smart contracts or Solidity contracts. They can both call each other, and it works just out of the box. Thanks to the WASM virtual machine, we have faster execution and lower gas fees, because operations on WASM virtual machine are much faster in comparison to the EVM. Thanks to the Arbitrum Stylus, we also have better security, higher security, because Stylus disables reentrancy by default. Now let's check the stack around Arbitrum Stylus. So what we have? Stylus SDK, it is a Rust SDK, but it can be any other programming language SDK that provides set of tools, libraries, components to build your own EVM-compatible WASM smart contracts. Also, we have a cargo stylus, and this is a command line tool that gives us possibilities to create a new project, build our smart contract, deploy it, and do some other stuff around this. Also, we have a Nitro node, and Nitro node is nothing besides the Arbitrum node that holds multi-VM, multi-virtual machine, both EVM and the WASM virtual machine. Now let's try to build our first Stylus contract. So let's generate the project with the cargo stylus command, and as we can see on the screenshot, it generates for us just a regular Rust project. And within this project, we need to check 3 files. Cargo tom, the first file that we need to check. In this file, we have information about the smart contract name, some of the metadata like the author, repository, license, stuff like that. And besides that metadata, we have also information about all the dependencies. So dependency management comes from the cargo tom file. The great thing around Arbitrum Stylus is that we can use any Rust crate that we want to in our Stylus contract, and it just works. Another file, I would say the most important one, is librs. In this file, we put all the logic around our smart contract. The last but not least, main.rs file. It holds some logic around displaying our smart contract interface, but we will go into this part later. Okay, so for today's talk, we're gonna build just a simple counter. So let's start with defining the storage. Every Stylus smart contract is built like a Rust structure that holds some data, and in our case, we just need to store the current counter value. To have our Stylus contract, we need to use 2 Rust macros that come from the Stylus SDK. The first macro, storage. This macro generates for us the Rust code to interact with the EVM persistent storage. So with this attitude, we can just store values for our counter and also retrieve the value from the storage. The second macro, entry point. This macro generates for us all the code that we need to interact with our Stylus smart contract. Of course, that's a very basic contract, but once building our own, we can use any data type that we know from Ethereum, like integers, maps, string, vectors, addresses, anything that comes to our mind. Now, it's time to define some logic for our smart contract. And to begin with, to give you more perspective about Rust, any logic in Rust is defined in implementation blocks. A Rust structure can have many implementation blocks, but the most important one is the one with the public macro. The public macro exports all of the functions that we have in this implementation block to be smart contract functions. So our counter smart contract will expose functions like value, increment, and decrement. As you can see, those functions are just regular Rust functions, so they can return a value like unsigned integer. They can return an error. They can panic, as we can do in Rust. The second implementation block shows us how to interact with the EVM stuff, like, for example, emit an Ethereum log. Also, how to retrieve some information around the context, like the message sender. Of course, the Stylus SDK provides many other functions to play with the EVM stuff. Having mentioned errors, having mentioned events, now let's try to define them. As you can see in the code snippet, we use just a Solidity syntax to define both errors and events inside Sol macro. So Sol macro is a Rust macro that, based on the Solidity syntax, generates for us all the structures, all the Rust code that we need to build EVM-compatible WASP smart contracts. There is one thing to be mentioned, that in Rust, we need to strictly specify what type of errors our function is going to return. We may know that we can have with function bunch of errors to be returned, Solidity errors to be returned. So we need to take the attitude of having just an enum, and to have a binding between Solidity errors and our Rust enum error. We just need to use derive Solidity error. We also need to take care and assure proper quality of our contracts. The problem is that we cannot just use pure Rust test to write tests for our Stylus smart contract. It is due to the fact that we need some kind of EVM emulation. We also need some kind of WASM virtual machine emulation. And to solve that problem, to solve that issue, my team at OpenZeppelin built a library called Motsu. It is a unit testing library to test our Stylus smart contracts. To write a Motsu test, Stylus unit test, we need to use just Motsu test macro and provide information. Which contract are we going to test? And also the list of the addresses that we're going to use in our test scenario. And as you can see in our code snippet, we can execute any of our smart contract function on behalf of a specified address. The great thing about Stylus SDK is that the Off-Chain Labs team, the team that builds the Stylus SDK, with the newest version of SDK, introduced some changes that allow us to modify the context in unit test, which makes the testing easier and allows you to write your own testing tools. Okay, so we have our contract ready to deploy. So let's deploy it. For deployment, we can use Cargo Stylus tool. And during the deployment command, it sends 2 transactions to the Arbitrum chain. The first one, called deployment, it just posts WASM on-chain. The second one, called activation, does some operation on the WASP binary. Now it's time to introduce a term that might somehow trigger you, and the term is cache. Interesting, cache in blockchain. But The problem is loading wasm binary from hard disk into memory takes some time, and to reduce that time, Off-Chain Labs team brought the idea of cache. The cache is nothing more than quick access memory, and we can store in cache at max, if I remember correctly, 4,000 smart contracts. Everything is managed by the cache manager contract, and to place a smart contract in cache, we just need to place some bit, and we have it hashed. We can also use our Cargo Stylus tool to check the minimum bit for the smart contract and place it in a cache. Now we want to know how to interact with the smart contract, so let's check the main RS file. In this file, we have a single one instruction called print ABI, and once we execute Cargo Stylus export ABI command, it generates for us Solidity-like ABI interface. It looks exactly the same as for Solidity contracts. So it means that we can interact with our Stylus contracts in the same way that we interact with just regular Solidity contracts. Of course, we may want to build more advanced smart contracts that are composed from smaller smart contracts, and it is also possible in Stylus too. We just need to create another structure that contains all of the components, all of the smaller smart contracts, and we need to make use of both borrow and inherit macros. Those macros we need to use to have the possibility to export all of the components contracts functions to be available in our ERC20 example. So thanks to borrow and inherit macros, we have by default exported all of the functions from ERC20 metadata, capped and pausable contracts. Additionally, if we want to, we can also override some of the functions from our components contracts, like I did for the decimals from the ERC20 metadata. All of the contracts that are mentioned here come from our OpenZeppelin Stylus contracts library that my team was working on. So I strongly recommend you checking out our repository, playing with our contracts, and suggesting ideas what we can build in the future for the whole ecosystem. The question is, right now, if we Stylus developers miss Solidity, there are some stuff that I want to discuss right now. So at first, constructors. Right now, Stylus does not provide constructors. We just need to use initializers or do some workaround and injecting some code during the deployment. But the grand information is that the PRs bringing Stylus constructors are already merged to the main branch. So we can expect them very soon. The next point is that smart contract composition. As I previously said, we can have only a single public macro. And that design decision prevents us for making use of the power of Rust traits and auto-implementing some of the interfaces. Another great news is that the Off-Chain Labs team is working on improving the developer experience, and we should also have the changes available in the next couple of releases. The next thing, Solidity modifiers. To be honest, in Rust, we don't need modifiers. We can just play around with stuff with regular Rust functions. The last thing is that we can't have multiple Rust functions with the same name that differs in arguments. But due to some fact, we may need to have in Solidity same function names, and for that we can use just a selector macro. Now it's time to explore the power of Rust and Stylus. I always say, don't trust, verify. And we decided to build a Poseidon hash in Arbitrum Stylus. And with this implementation, we built our own optimized big integers library We also applied some tricks with WASM multiplication using the more efficient data types. We did some Rust tricks with function inlining because calling function takes some CPU time. Also, we did some Rust tricks with unrolling code loops. And in the end, we used WASM optimizations on our binary with WASM op tool. And we did some benchmarks with 3 smart contracts. The first smart contract with Poseidon implementation, the pure Solidity, let's say easy to read, maintain, and audit. The second implementation called Yule, it's a Poseidon implementation in Solidity assembly. And also, of course, our Rust implementation, Stylus implementation of a Poseidon hash. And to be honest, we were so amazed with the results. We get 18th time faster than the Solidity implementation. Another use case that we may want to consider that we touched in the past are Uniswap v4 hooks. We can imagine that we may want to do some intense computations in our smart contract, but we can move the logic to the Stylus smart contract to speed up the computations and just call the logic from our Solidity hook. For example, that computation may be custom curves in pricing models. There are a bunch of many other use cases that we can leverage the power of Rust and Stylus, and those examples are, for example, on-chain verification with ZK proofs. Additionally, we may want to build some advanced DeFi instruments, not only Uniswap hooks, but anything else. We can also we may want to build some high-performance on-chain logic, like on-chain games. We may want to optimize our current protocols by moving the intense computations to Stylus contracts. And just to summarize, we have endless possibilities, what to build with Stylus, how to speed up our protocols, everything. That's all from my side. Thank you so much for your attention. Do we have time for questions? Okay. So thank you so much. If you want to join OpenZeppelin, just scan the QR code, check the open positions, and apply. Thank you so much.